Hello and welcome to another episode of the Williams Learning Lab. In this episode we're on the topic of atomic structure, and we're going to learn how to do electron dot notations of individual atoms and of molecules. So you are going to need a periodic table for this. The method that I like to use is I look at the number of valence electrons that an atom has, and then I see the unpaired electrons because I know that's where they're going to bond. And I just make sure all the electrons get paired. There are some other methods, but this is the one I'm going to be using in this video. If you need a review on determining the number of valence electrons in an atom, so we're just going to look at the groups. Now, this doesn't necessarily work for the transition metals, the ones that I have in yellow here. The transition metals, you can assume usually that they are 2. Check with your instructor, but really they're more complicated than that. The lanthanides and actinides, often people will assume that they're 2, but they are really more complicated than that. Now, the ones that are very predictable for are the group 1. Group 1 has 1 valence electron. Group 2 right here has 2 valence electrons. Group 13 has 3. Group 14 has 4. Group 15 has 5. Group 16 has 6. Group 17 has 7. Group 18 has 8. Except for helium, it has 2. It's a tiny one, so 2 is all it can handle. So what I like to do for this, whenever I'm doing electron dot notation of an atom, sometimes it's called a Lewis dot structure. That would be of an individual atom. Step 1, I write the symbol of the element. Step 2, I determine the number of valence electrons. Step 3, I add dots representing the number of valence electrons. And for step 4, I write the dots on all 4 sides before pairing the electrons. And so generically, I'll write a element. We'll call it element X. There is no element with the symbol X. There is no particular order you have to go. You can start anywhere and you can put your electrons anywhere you want to. The rule is that you want to make sure there's at least 4 unpaired electrons before you start pairing them. The method I like to use is I start at the top and I just go around in a circle, right? Do it the same way every time because it helps me remember. So I have 1, 2, 3, 4. Now I have 1 unpaired electron on all 4 sides, and this would be the 5th, 6th, 7th, and 8th. So that's the order that I like to use. The important thing really is that they don't pair until the 5th electron. So let's go ahead and let's do an example. All right. So we have oxygen right here. Let me get organized. There we go. So oxygen, if you look at the periodic table, it's a group 16 element. So it is going to have 6 valence electrons. So I'm just going to say 6 right here. Now the electron dot notation is what we're going to do here. I said step 1 is to write the symbol. Oxygen has a symbol of O. And step 2, determine the number of valence electrons. We just did that. It has 6, and we're going to add the dots that represent those 6 valence electrons. And we're going to keep going on around all 4 sides, and then start pairing at the 5th until we just run out. So 1, 2, 3, 4, 5, 6. And so that would be the electron dot notation of oxygen. Well, let's do another one for boron. Boron's in group 13, and so it has 3 valence electrons. The symbol for it is a capital B. And then we are going to put the valence electrons unpaired until we run out. And there we go, we have 3. The reason why this is significant is, for example, in oxygen, it has 2 unpaired electrons, so it can make up to 2 bonds. Well, it makes 2 bonds, not up to, it makes 2 bonds. So boron, it has 3 valence electrons, and so it can make 3 bonds. Let's do nitrogen next. It is a group 15 element, and so nitrogen is going to have 5 valence electrons. The electron dot notation, you're going to use the symbol, that's a N, and then we are just going to go around and put the electrons. 1, 2, 3, 4, 5. And so the significance here is we have 3 unpaired electrons, so that'll tell us that nitrogen likes to make 3 bonds. Let's do carbon next. So for carbon, it is a group 14 element, so we are going to put, that's a symbol. So group 14 has 4 valence electrons. So for the electron dot notation, I am going to put the symbol and then my 4 valence electrons. 1, 2, 3, 4. As you get practice with this, it will get easier and easier. So let's see what we do when we are making actual molecules. All right. So for the electron dot notation of molecules, step 1, you write the electron dot notation of each element in that molecule. That'll help you visualize how many connections it can make. Step 2, connect unpaired electrons of each atom together until each atom's octet is full. So here is an example that I have right here. Draw HBr using electron dot notation. All right, and so if we look at hydrogen on our periodic table, hydrogen is going to have 1 valence electron. So I'm going to put the symbol and add 1 valence electron. For bromine, we look at the periodic table. Bromine has 7 valence electrons because it's a group 17 element. So its symbol is Br. And then we're going to put its 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Now as we analyze this, we can see that bromine has 1 unpaired electron and hydrogen has 1 unpaired electron. Because of the octet rule, atoms want to have 8 valence electrons, and if they don't have that, they will share them until they get 8. Hydrogen is an exception because it's happy with 2. Helium is also happy with 2, but it doesn't bond, so we don't have to worry about that so much. So I'm going to write our hydrogen electron dot notation. And so if I want to draw the structure of hydrogen bromide, HBr, then I am going to set them side by side, and the unpaired electrons will be together, and that's what forms a bond. In a chemical bond, there are 2 valence electrons being shared for covalent bonds. All right, so let's do a couple more examples. All right, the first one is a very common example of water, a very important molecule. Hydrogen electron dot notation, we just did this. All right, symbol is H, and it has 1 valence electron. Oxygen, we previously did this one. Oxygen, symbol is O. Since it's in group 16, it has 6 valence electrons. So we're going to do 1, 2, 3, 4, 5, 6. So we are tasked with drawing H2O using electron dot notation. And so this 2 right here tells us that there are 2 hydrogens. And if we look at our oxygen, it makes sense that it's going to need 2 hydrogens because oxygen has 2 unpaired electrons. Each individual hydrogen can share 1 electron. And so I'm going to put oxygen in first, just redrawing what we drew. So we have that right there. And if I put a hydrogen right here, we can see that we have a covalent bond between them. And we can put another hydrogen right here. Okay. Now that by itself electron, that lone electron, that unpaired electron, they can be on any side of the element. So they don't just have to be on the right or the top or the bottom. An atom doesn't know which side's up or left or right. So you can put that single electron anywhere. So here, put that single electron above the hydrogen. Over here, it was to the right. All right? No issue with doing that. Next, let's try, let me adjust my camera just a little bit. Let's try doing carbon dioxide. Now, this one's going to be a little bit more challenging, so let's just check it out. Carbon, we just did this one. Its symbol is C. Because it is in group 14, it's going to have 4 valence electrons. So 1, 2, 3, 4. Now this carbon, because it has 4 unpaired electrons, that means it's going to make 4 bonds. It needs 4 additional electrons to fill its octet. We'll redraw oxygen here. Just did that on top. It's got 6 valence electrons, 2 unpaired electrons. And if we look at our molecular formula right here, our 2 after our oxygen says there are going to be 2 oxygens for every 1 carbon in this molecule. So what we're going to do here, the unpaired electron of carbon right here is going to share with the unpaired electron of an oxygen. Well, it's going to make something called a double bond because it's going to make 2 connections between this carbon and one of the oxygens. So we'll have a connection with these 2 and the 2 that I have pictured here on the bottom. So I'm going to put carbon as my central atom. Usually, if you're looking at your molecular formula, the first element is the one that's going to be in the center, unless it's hydrogen. Hydrogen's always on the outside. So now I'm going to put my oxygen. So I'm going to put the lone pair electrons, the ones that are already paired on the outside. But this electron and this electron that I'm pointing at, they're going to go between the carbon and the oxygen. And so since we have a total of 4 electrons here, or we could say 2 pairs of electrons, then we can say that's a double bond. Well, we represented carbon 2 of its lone pair of electrons, but we see that it has 4 over here. So we're going to have one more oxygen, and I am going to put the lone pair electrons, but oxygen needs to share 2. So I'm going to put its 2 right here, and then carbon needs 2 more to share, so it's going to be right here. And so what we have here is the electron dot structure of carbon dioxide. As you start getting to the double bonds and triple bonds, it gets messy and a little bit more complicated. And so the way we're going to simplify that is we're going to start doing something called Lewis structures. All right, and I will have that for you in the next video. And I hope you found value from this video. If you did, would you consider commenting, or subscribing? If you have any questions, leave them down below. If you'd like to see me do any specific examples or show you another method to do this, leave a comment. And until next time, thank you for watching and keep on learning.